This video helps us understand how to multiply rational expressions, and we're going to look back at kind of some of our fraction rules and ways that we reduce fractions to help us better understand a little bit about what's happening when we multiply rational expressions. So first off, I have 16 over 24, and what I want to do is I want to use our understanding of what 16 is to break this down in some of its element parts. And so I know that 16 is 4 times 4. And I know that 24 can be broken down even more into 2 times 12. And so we're going to use these relationships, and we're going to break it down even more. So each of those 4's can be broken down into 2 times 2, that's the first 4, times another 2 times 2 for the second 4. And we're going to keep breaking this top guy down. So 2 times 12 can be broken down, let's say, into 3 times 4. And so our final solution is 2 times 2 times 2 times 2 on the numerator. And then on the bottom, on the denominator, we've got 2 times 3 times 2 times 2. Okay, so now I have this broken down. This is called prime factorization, but that's not essential at the moment. And we see we have 2's on the top and we've got 2's on the bottom. So every time I see a 2 on the top, like for example here, I see another 2 on the bottom there that can cancel out. And I can cancel out kind of any which ones that I want, so long as I can cancel one out on the top and then another one out on the bottom. And so what am I left with here? I'm left with just this 2/3 here in the middle. I'm left with this 2/3 in the middle. And so that's actually my answer. My answer is 2/3. All done. When we're multiplying polynomials, when we're multiplying fractions, it's actually one of the most simple processes in math. So we've got this 2 over 3 times 1/2, and all we do is multiply straight across. We just multiply straight across. So this is going to be 2 times 1, which is 2, divided by 3 times 2, which is 6, and we can reduce that even further just to 1/3. So this is multiplication at its most simple. Let's start looking at polynomials. So if I have a polynomial like this, there's a few things that I can do. I can break them down to make it more simple for me so that I'm not having to do quite as much math in the future. So if I see a problem like this, and I'm actually going to switch my colors so that you can tell the difference from the original problem to not the original problem. So I'm going to simplify this. So 16 can be broken down into 2 times 8. And 14 can be broken down into 2 times 7, and then we have all of that times our original 8n over 2. And I like to do this so that I can start canceling things out that are able to cancel out. I see there's a 2 there, there's a 2 there, and I can probably do this one more time. Oh, I forgot an n on the denominator here. There we go. We've got an n all the way. All right. So let's do it one more time. I see that 8 can be broken down, so I've got 2 times 4 over 7n times 8n over 2, and I can cancel out those 2's because there's one on the top and there's one on the bottom. And now I go ahead and multiply straight across like we did with the fraction. So 4 times 8 is 32, and 7n, well, the 7n has nothing to multiply with, so it's just left with 7n. And hey, look, I've got an n on the top and on the bottom. Those guys get canceled out, and I simplify to 32 divided by 7, and this is actually our final answer. We've got to answer one more thing before we finish, and that is, what can x not be? Or in this case, what is excluded from the denominator? Which value of n is going to make our denominator 0? And that's kind of simple because all we do is 14n equals 0. How do I get n by itself? Well, I divide by 14, divide by 14, n is 0. So in our original problem, n cannot be 0 for this to be the correct answer. So there's what that I want to do with us, and it looks a little bit complicated. It looks really scary, but if we actually break it down and we start factoring, it's really not quite that bad. I'm going to switch my color again to that yellow so you can see the difference. Right off the bat, I see, oh, I have an x plus 8 on the top and an 8 plus x on the bottom. Those are really in parentheses. And because they're multiplication, we have the prime opportunity of canceling them out. And I'm going to even simplify this even more. So they cancel out, and we're left with just ones there. Yeah, when things cancel out, they become ones, which, unlike addition, when we cancel out with multiplication, things become ones. When we cancel out with addition, it becomes ones. I think I said that wrong. Let's take a quick look. I'm just going to add these, multiply these across. So I'm left with 6x plus 36 on the numerator and 6x plus 12 on the denominator. Well, I see that 6x and 36, they have a 6, and 6x and 12 have a 36. So in my next line, I'm going to factor out a 6 from the top and the bottom. So I've got 6 times blank over 6 times blank. Well, that's an x plus 6, because 6 times 6 is 36. And this is just an x plus 2. I see a 6 on the top and the bottom. And my final result is x plus 6 over x plus 2. And we've got several exclusions in this example. We've got to take care of 6x plus 12 can't be equal to 0, and x plus 8 cannot equal 0. And these are coming from this original numerator. So this 6x plus 12 is coming from up here, this 6x plus 12. And this x plus 8 is coming from this x plus 8. So all I'm doing here is just a little bit of Algebra 1 stuff. Minus 12, subtract 12. 6x cannot equal negative 12. Divide by 6, divide by 6. X cannot equal negative 2. So that's part of my answer at the top. And then again, subtract 8, subtract 8. X cannot equal negative 8. So those are my two extraneous solutions. So if I were to plug those back in to the original equation, the problems that I would get is that my denominator, or the bottom of my fraction, would become 0, and that's a huge problem, because then we have an undefined rational expression. So I hope this helped with these 3 examples.